Okay, I've just realised you need a title. So, title for today's lesson is Forced Harmonic Motion. So, for us, this is basically where you force a system into a simple harmonic motion, which may otherwise not be simple harmonic motion. But I'll go through an example. So, example 10, page 183, I think, in your books. It's there or thereabouts, anyway. And then we've got this F equals ma situation again. So, a particle P of mass 1.5 kilograms is moving along the x-axis. At time t, the displacement of P from the origin is x meters. So there's P, distance of x, and the speed of P. This v. I'm going to take the motion as going this way, just because it's an easier model if everything's acting positively. So that's definitely going to be our positive direction anyway. Three forces act on P, namely a restoring force of magnitude 7.5x. So the restoring force is always trying to bring you back to the origin, because we're looking for this oscillation about the origin, so it's always pulling you back. So that's going to act in towards the origin, and it has magnitude 7.5x. A resistance to motion of P of magnitude 6v. So P's going this way, and so plus 6v acting in that direction, and a force of magnitude 12 sine t acting in the direction OP. So that is going that way. I know we looked at this last lesson briefly. If the particle is actually moving in the negative direction, then I'll move it over here. But these questions they feel a bit weird. I had to kind of think this one through, because you have the restorative force that is pulling you back in towards the centre. And then you have 12 sine t acting out this way in the direction of OP, so that's not changed. But the resistance to motion will be going this way, so it's really, that's what you kind of feel like you should be doing. But because V is negative when you're travelling in this direction, this is the magnitude of the force here. So you actually end up with 6 lots of minus V to give it the magnitude that's of a force. So we don't really write in negative forces as such. And then you will end up with the same equation. So you'll still get 7.5x plus 6v. So because the velocity changes sign, this will work whichever direction P is travelling in. So you might just need to think that through just for your own understanding. I needed to, because I get confused otherwise. So if you're like me, have a think about that. If not, just carry on. Don't worry too much. Which is fine. Sometimes I wish I didn't overthink things quite as much as I do. It'd make my life much simpler. Right, so we've got F equals ma, so resultant force. So I have 12 sine t minus 7.5x minus 6v is equal to the mass times the acceleration. So we're basically at F equals ma. And then turning this into a differential equation, I've got 1.5 times the acceleration plus 6 lots of the velocity plus 7.5x equals 12 sine t, and then dividing through by 1.5. So plus 4 dx dt. Try not to smudge it, sorry if I do. Plus 5x is equal to 8 sine t. So that's part A. Part B is going to be solving this. I did debate whether to do this on here. I will, but I'll do it on the next video. It's quite long and you've done a lot of them, but you might just want that recap. So I'll solve it on the next video.